Drone is becoming more popular nowadays. It's also known as unmanned aerial vehicle. A drone can be either controlled remotely or flying in the autonomous mode through the software control flight plans embedded in its system. In most cases, onboard sensors like GPS can be equipped on the drone for purposes like location tracking. From the graph on the right, we can see the predicted commercial growth of the drone market. The most common usage of the drone is in the aerial photography, while some also will use for product deliveries in the agriculture sectors, infrastructure inspection, as well as used in the research and development purposes. For the problem statement, the drone flight time is limited by the battery capacity as well as the weight of the drone. Even when the drone have a very large battery capacity, it always comes with a very heavy weight, and therefore the range of the flight time is still limited at an average time about 10 to 30 minutes. The manual battery swapping and charging also limits the drone coverage. Moreover, the accuracy of the GPS is still not precise enough in the landing process, where it will still come with an error of within 3 meters. The current solution in the market now offers high battery capacity to increase the flight time, but it always comes with the limitation in the payload increment. The manual landing are assisted with GPS. However, the range of coverage is still very limited because the drone still cannot land very precisely to the targeted location. Next, the wireless charging of drone can reduce human intervention in the charging process. However, the charging efficiency is still very low, with the low power output as well as the long charging time required. In this project, we are proposing an effective solution for the drone charging process, which is the autonomous landing using marker tracking technology, where the drone can land autonomously to the targeted spot with high precision so that it requires no human intervention to help in the charging of the drone. It also will increase the drone coverage. The energy harvesting using Rectana involves the wireless charging without power source. The Rectana harvests the ambient energy and then convert it into electrical energy, so it can provide the power to the microcontroller infinitely without having to charge it using any wired or inductive charging equipment, or even with battery. The battery of the drone does not need to provide the power to the microcontroller, which is the Raspberry Pi, and therefore it reduces the workload and extends the battery life.
So in demo and user feedback, we have given three of our close friends to try out our system. So Tu Junchuan shared that he likes how accurate the landing is, but he dislikes how complicated the interface to use the landing system can get. Whereas Chu Jiashen has also shared that he likes how accurate the landing is, but the setup for the landing system is complicated and time consuming for him. And lastly, Chojoe shared that he likes how fast the landing is, but he disliked how inaccurate the landing can get in the presence of a strong wind. Moving on to target segment impact, there's two main sectors that we have identified that will benefit greatly from our project. The first sector is courier companies such as Post Laju, DHL, Grab, Amazon, and so on. So the type of benefits they can get is such as higher parcel delivery efficiency, a higher work productivity, as well as to lower the labor costs. And the second sector that will benefit greatly is the medical sector, such as hospitals, Red Crescent Society, as well as the St. John Ambulance. This is because they can ensure a faster delivery of blood pack during times in need, as well as a faster deployment of first aid kits to civilians during crisis.